This is our convection current lab. So with the convection current, remember that it's dealing with liquids and gases. In this case, we are going to show what happens in a convection current in liquids. Reminder that, right, in a convection current, cold liquids and gases sink because it is more dense, and warm gases and liquids rise because it is less dense. So in this demonstration, you will see this happening in a liquid. So what I have here is a bottle that has water in it that's chilled, and we put blue food coloring in it. And we have a bottle here that has water and red food coloring in it, and we warmed it up in the microwave. Our tank here has just room temperature water. What we will do is we will place both bottles into the tank, and we will put it at the bottom of the tank. I will take off the lids, and you will observe what happens in a convection current. Okay, so here we go. Opening the blue bottle with the cold liquid, and this is the other bottle, the red liquid that has the warm, that is warm. Looking at the liquid that's coming out of the bottle, you should notice that the one on your left, the red liquid, is rising. It is rising because the red liquid, the liquid inside is more hot, so it becomes less dense. And then the cold liquid, the blue one, is more dense than the temperature water, the room temperature water around it. Therefore, it is staying on the bottom because it is more dense. Okay. We're going to let some of the liquid come out, and then what we will do is let's stand up the bottles and let's see if it changes anything. With the red bottle, if we stand it up, the red liquid should continue to rise because it is still hot. And let's see what happens with the cold blue liquid. You can see the red liquid is rising, and it's almost creating this layer of red liquid on top. The reason why is that red liquid is warmer, and it is less dense, and it's rising and it's staying on top because it's still warmer and less dense than the rest of the tank. The cold blue liquid, right, doesn't seem to be doing much, but the liquid is not really coming out of the bottle because it's still more dense and more colder than the rest of the water in the tank. Let's see what happens if we put the blue one back down. Okay. And while I'm putting my hands in here, I can tell a difference between the water temperature. The water on this side where the blue cold liquid is, the water feels much cooler than the water is on the side that has the warm red liquid. And you can see the blue here, now that we've tilted or put it back down, the cold blue liquid is coming back out of the bottle, and it is still staying at the bottom because it is more dense than the rest of the water in the tank. Now, pay attention to this red liquid here because it is less dense, because it is warmer. It is rising, and this will be a good demonstration, because in the next couple of chapters when we talk about weather and how clouds are created, keep this in mind, because that red liquid, the warm liquid, is rising and it's less dense. This is really how clouds and storms and so on develop, because of this warm air rising. And the blue liquid is continuing to come out, and eventually, if we left this going for a while, what should happen is those two colors and liquids should mix, possibly turning the tank purple with red and blue mixing together. But right now the red still seems to be at the top, and it still looks like that red liquid is coming out pretty fast. So this concludes our lab on the convection current. So we're back at the convection current lab, and it's been an hour and a half since we've put in the bottles, and we wanted to see if the liquids mix and if we get purple and so on. And so it's been an hour and a half, and we can see that the red warm liquid has somewhat moved down, and the cooler blue liquid has somewhat moved up. The warmer red liquid has moved down because it's become less dense. More dense. It's gotten warmer, and it's cooled down. The warm red liquid has cooled down, causing it to be more dense, and it is starting to sink. The cooler blue liquid that was more dense has warmed up, and it is starting to rise. Now let's see, if I put my hands in there, let's see if the temperature of the water feels any different. Before, on the right side over here, your left side, the warmer red liquid made the water around warmer. Right now, let's see, doesn't feel too cold. It is still colder on the side with the cooler blue, more dense liquid, and there is, yeah, you can feel a temperature difference. And let's see if we feel a temperature difference as far as bottom to top. I'll go in the middle. Still cooler. Slightly, but not too much. Let's go on this side. Yeah, actually, as I'm going lower here, it does feel cooler than it does up here. So that is consistent with the convection current, and warmer liquids being less dense and rising, and cooler liquids being more dense and sinking.